Okay, welcome back to Andy's. This time we're going to solve a little bit more difficult of a problem and show you some other parts that come into play when you're trying to solve problems to help make Andy's a little bit easier to use. Let's go ahead and start out just by figuring out what we're dealing with. We have a ball at rest. Two walls that are holding it in place are exerting forces on it. It weighs 2 kilograms, and we're supposed to find the magnitude of the force exerted by wall 1. Like we did before, we want to just start enumerating the bodies. We want to put all of the information that we get from the picture down on this canvas, just like we would on a piece of paper. So I'm going to start out with an axis, and I'm going to drag it out right here. It gives me my X and Y. I'll accept the default. Okay, and it turns green. So I can do it with this orientation for the axis, and honestly, it'll probably be easier if I do, but I'm going to show you a more difficult way, and then you can stick to the easier ways when you're solving problems. So I'm going to rotate this up and so that it matches the picture. And you see the picture has it at 30 degrees. Okay, I didn't quite get 30. 30 degrees. Okay, so now it's green because it accepts this orientation for the axis. So I have my axis, and I'm going to draw the ball. Okay, and now I need to start drawing forces. The most obvious force would be the force of gravity coming down on the ball. So I'm going to go ahead and go straight down here, 270. And I'm going to say this is Fg. Well, why don't we say this is just force 1? It's the force of gravity on the ball, and it accepts that, so great. Now I'm drawing a vector of force coming out of the ball, the normal force being exerted by the wall 1. That's going to be up in this direction, and if you take 30 degrees and find the perpendicular angle, that would be 90 added to that, so we get 120. And so F2 will be normal force of wall 1 on the ball. And now I'm going to do wall 2. And if we take perpendicular to 50 degrees coming up from that side, then we're going to get 40 degrees on this side. And so I'm going to say F3 is the normal force of wall 2 on the ball. Okay, so now I have my forces drawn, I have my axis, my ball, and now I need to put the 2 kilograms that I got on the problem here somewhere. Now if I do that right now, I just say ball equals 2 kilograms. I'm going to have a problem. It turns red because Andy's complaining. It says, I never defined the variable ball. Anytime you want to use an equation, you have to define your variables first. So I'm going to delete this. I'm going to come over here and I'm going to grab the text tool, and I'm going to tell it what part of the ball I'm focusing on. So I'm going to say B, and I'm going to say it's the weight of the ball. Okay, so it turned green, but you'll notice that over here it says it interpreted my definition as the mass of the ball, and in the problem it asked, or it told me that the mass was 2 kilograms. So I probably should have written mass, but it understands weight. Okay, so now if I come over here and I grab my equation tool and I draw B equals 2 kilograms, it will accept it. If I'm stuck and I just don't know what to do, I can click here on the question mark, and it says you've already defined all of the given quantities. Let's think about a strategy. Please enter the quantity I'm looking for. Okay, so I'm looking for, in the problem it said I'm looking for the force exerted on the ball by wall 1. And when I drew it, if you see over here, I defined F2 as the normal force of the wall on a ball. So wall 1, this is what we're looking for. So I'm going to put down here, I am looking for F2. And click there. It says, yep. Which principle would you like to apply first? Okay, so this force is a force in the y direction. So if I use Newton's second law, with the y components, that should give me my answer. So I'm going to click on this one, and it tells me that I have chosen the correct law, and it says it's going to be easier if I rotate my axis. And like I said before, I'm going to go the hard way. You can do it the easy way if you want to. So I'm going to say no. I'm not going to change my axis. So now I'm back here, and I know the principle that I'm looking for. Okay, so it was really handy that the help tutor gave me the principles so I could choose from them. But that's not the only place that I can get the principles from. I can also go up into physics, click on principles, and get them this way. Now, right now, I'm looking for, I need to find the force of the weight. Well, if I come down to force laws, I find the force of the weight equals mass times gravity. I'm going to close this, and I have a force down, which is the force of the gravity on the ball. And if I go ahead and come over here, I can say F1 equals mass, which is B, times gravity. And you'll notice up here I was given gravity as part of this problem, so I can just push G and it will accept that. So I have my force F1. And now I can start breaking down into x and y components. So why don't we start with F1, since I just barely defined it anyway. F1 in the x direction equals, we're going to say F1 times negative sine 30 degrees. And I'm going to do the y direction. F1 y equals F1 times negative cosine of 30 degrees. And like I've mentioned before in other tutorials, to get the x and the y component of a force, you just push the underscore and then x or the y. So that's F1. We have that one ready to go. F2, let's say F2 in the x direction equals, and it's perpendicular to the x direction if you remember when we drew it out, so I can just push 0, enter, and that's correct. And I'm going to put in the equation F2y equals F2. Now I just have to do F3. F3 in the x direction equals, if you remember, it was 40 degrees and our axis is 30. So that means that we have to have F3 times, in the x direction will be cosine of 10 degrees difference. And we do the equation again. F3y in the y direction equals F3 times sine of 10 degrees. And again, if you forgot to use degrees as the units, we have units up here. Just click on here and I come down, and here DEG is 4 degree. So now I have all of my x and y components. So let's go ahead and let's say F1y plus F2y plus F3y, y. So all of the forces in the y direction should sum to 0, according to Newton's second law that we figured out for our strategy long ago. Click enter, and it accepts that. And just to be thorough, we're going to come over here and say F1x plus F1y, or F2x plus F3x equals 0. So now my sum of forces, all my equations are ready in place, and now we can solve. So we're going to say F2 equals question mark, and that is the force of wall 1 against the ball. So I can come over to my answer, click here, I'm going to say 15.25 newtons, enter, and it accepts it. Got my answer. Got 100%, and now we're done. We click submit.